Hello everyone. In this video, I will discuss how to synthesis of RC passive network using first of all. This is another example. You can see the impedance function of the RC network is this one. We said RCS is equal to S plus 1 times S plus 3. The denominator is S times S plus 2. Before construct our circuit, we have to check the function is realizable or not. For that one, there are set of general properties for RLC circuits or RLC networks. We have to check those properties. These are the six properties. The first one is must be a rational function in S with real coefficient. It is a function in S and it has real coefficient. Then first one is okay. Then second one is may not have also zeros in the right half S plane. For that one, we have to find poles and zeros. We can obtain poles from the denominator. Poles are S equal 0 and S equal minus 2. Poles mean the roots of the denominator. And zeros we can obtain from the numerator. There are two zeros at S equal minus 1 and S equal minus 3. These are the roots of the numerator. When we plot those poles and zero in complex S plane, this is real axis, imaginary axis. There are two poles at the origin and at minus 2. And when we consider zeros, there are two zeros at the minus 1 point and minus 3 point. And when we consider the S plane, this is the right half plane, positive side of the real axis. You can see there are no any poles or zeros in the right half plane. Then according to the second property, it is satisfied. And third one is may not have multiple poles or zeros. There are no any multiple poles and zeros. It is also satisfied. And fourth one is may not have the degree of the numerator and denominator differing more than 1. For this one, degree of the numerator is 2 and the degree of the denominator also 2. The difference is 0. It is less than 1. Then fourth condition also satisfied. Differing by more than 1. May not have the degree of the numerator and denominator differing by more than 1. The difference is 0. And fifth one is must have non-negative real part for all S equal j omega. For that one, we have to assign S equal j omega to this function. I will assign that one. Said RC S is equal to squared plus, I simplified the function, plus 3 over squared plus 2s. Now I assign S equal j omega squared plus 4j omega plus 3 over j omega squared plus 2j omega. You can write 3 minus omega squared plus 4j omega over minus omega squared plus 2j omega. The denominator has a complex number. To find the real part of this ZRC, we have to divide the both numerator and denominator by complex conjugate of the denominator. 4j omega times complex conjugate is omega squared minus omega squared minus 2j omega. The denominator minus omega squared plus 2j omega multiplied by minus omega squared minus 2j omega. After solving the numerator and denominator, we can obtain omega to the power 4 plus 5 omega squared plus j times 2 omega cube minus 4 omega squared minus 6 omega. The denominator is omega to the power 4 plus 4 omega squared. If we consider the real part of this ZRC, j omega, we can get omega to the power 4 plus 5 omega squared over omega to the power 4 plus 4 omega squared. You can see it is a real part. It is a non-negative. The fifth property says must have a non-negative real part for all s equal j omega. You can see this part is greater than 0. Then this condition also satisfied. And final one is must have a positive and real residue for all poles. For that one, we have to do the partial fraction expansion. And also for the first form, we have to do the partial fraction expansion for this impedance function. Then I will do the partial fraction expansion. Said RCS is equal to, I will simplify the function s squared plus 4s plus 3 over s squared plus 2s. For this function, the degree of the numerator and degree of the denominator are equal. Then I can write the partial fraction expansion like this. A plus b over s plus c over s plus 2. This is the partial fraction expansion constant plus these are the two roots. Then s squared plus 4s plus 3 is equal to a times s squared plus 2s plus b times s plus 2 plus cs. Then we have to find value of a, b and c. For that one, first I consider the s squared terms. One is from the left hand side, it is equal to 1, and from the right hand side, it is equal to a. Value of a is equal to 1. Then I consider s to the power 1. From the left hand side, value is 4. From the right hand side, 2a. From this one, plus b plus c. A is equal to 1. 2 into 1 plus b plus c is equal to 4. Then b plus c is equal to 2. Then I consider s to the power 0. From the left hand side, value is 3. And from the right hand side, b into 2, 2b. The value of b is 3 over 2. Then from this one, we can obtain the value of c. 3 over 2 plus c is equal to 2. And c value of c is equal to 1 over 2. Then value of a is 1, value of b is 3 over 2, and value of c is 1 over 2. In the sixth property, it says must have positive and real residue for all poles. From this partial fraction expansion, poles are this one, this is a pole, and this is a pole. Residues are b and c, value of b and c. You can see value of b is real and positive, and the value of c is also real and positive. Then that condition also satisfied. Then we can do the synthesis of network, passive network. It is RC network. Now we know the partial fraction expansion. Then I can write it again. Set the RC S is equal to value of A is 1 plus value of B is 3 over 2 OS plus value of C is half. Denominator is plus 2. These are Z1, small impedance part, Z2, and Z3. If we consider a capacitor with the value of C, we can write the impedance value is 1 over Cs and admittance is Cs. And also if we consider a resistor with the value of R, impedance of the resistor is R and admittance of the resistor is 1 over R. These terms we can help to develop the circuit. First I consider the Z1 value of 1 and it will be a resistor. We can see impedance of a resistor is value of resistor. There are no any S terms. Then value is 1 ohm. Then I consider Z2, it is 3 over 2S. There is a S term. Then if I consider the impedance of a capacitor, you can see impedance value is 1 over Cs. It is like to this Z2. It is a capacitor. Value is 2 over 3. We can rearrange this term 1 over 2 over 3 times S. Then capacitor value will be 2 over 3. Then I consider the last impedance value is Z3. It is 1 over 2 times S plus 2. For this one, I consider the reciprocal of this value. That means Y3 admittance value. We can get the admittance value 2S plus 4. If we consider the first part of admittance, it is equal to 2S. Then it is similar to admittance value of a capacitor. The system. Then this is a capacitor and the value is 2F, 2 farad. And when I consider this part, it is equal to resistor. There are no any S terms. Then value is 1 over 4 ohm. In the admittance tree, Y tree, the combination of capacitor and resistor are defined as plus mark. That means these two elements are connected in parallel. Capacitor and resistor. 2 farad and 104 ohm resistor. Then the total impedance is connected in series. Z1 connected with Z2 in series and Z3 also connected in series because of this plus mark. Then I can draw the final circuit. Z1 is a resistor with the value of 1 ohm is R1 and Z2 is a capacitor C1 value is 2 over 3 farad and Z3 is there are two elements capacitor parallelly connected capacitor and resistor. These two elements are connected in series with the resistor and capacitor. C2 and R2. R2 value is 1 over 4 ohm. C2 is 2 farad. And we can obtain the total impedance from these 2 points. ZRC. Yes. This is the final circuit that we can obtain for this impedance function by using the first of all. I think you all are clear about this example. Thank you.